This meeting is being recorded.
Chapter 2, Problem 15, gives us the structures below and then asks us to draw the resonant structures that are indicated by the curved arrows, which are shown in red. So we're told or reminded, rather, to include all formal charges. So let's take a look at A here. So we see that we have an allylic carbocation and the tail end of the arrows on the pi bond, and then we're moving those electrons to the other side. So we're not only going to be moving that double bond, but we're also going to be shifting that +1 formal charge to the other carbon. So you see in A drawn down here, that's exactly what has been drawn. So the double bond is on the other side and the cationic site is flipped. With molecule B, or ion B, I should say, we see a lone pair on one side with a -1 formal charge. The tail of the arrow is there, so we're going to move those electrons in to form a double bond. At the same time, the pi bond from the allylic anion here will start the tail of the second curved arrow, and those pi electrons will be moved over onto the other side, and that's where the lone pair of the anion will be. So very similar to A, we kind of flip our allylic anion here. Then we see in C, we have movement again of we have two arrows here, so one lone pair moving and then one double bond. Pi electrons are moving as well. So we're going to create a double bond in C between the carbon and oxygen down below by movement of that lone pair. And then you can see at the same time, we're going to move the double bond that was on that same carbon there up to become a lone pair on that oxygen. So now we have created a +1 formal charge on this lower oxygen and a -1 formal charge on the top oxygen. In structure D, we begin with a -1 formal charge with a lone pair on a carbon atom. We move those electrons and we form a double bond. So we see that indicated in molecule D. And then the double bond between the carbon and the nitrogen moves to form a second lone pair on the nitrogen. So that negative formal charge has shifted onto the nitrogen with 2 bonds and 2 lone pairs. Then we move to the second row that's drawn out here, and we see the answer for E shows with 3 curved arrows, we have movement of a lone pair to form a double bond between oxygen and carbon. So we can keep track of everything here. So that's right here. So that new double bond has formed. Our second arrow shows that a new double bond has been formed here with movement of the pi electrons from this region here. And then we see what was a pi bond here has become a lone pair down here on this carbon. So we see a -1 formal charge on the bottom of the molecule, and then we have a +1 formal charge on the top. Let's move to answer F here. So we again see 3 curved arrows. So with movement, we'll start at the bottom now. So movement of that pi bond at the bottom gives us a formal charge on this carbon of +1. Then we have movement of another pi bond to form a double bond now between the nitrogen and carbon. And that keeps that nitrogen with 4 total bonds because the last curved arrow moves the double bond between nitrogen and oxygen to a lone pair on the oxygen. So that nitrogen, as I mentioned, will remain with 4 bonds, so that means that it retains that +1 formal charge. But now we have a -1 charge not only on this oxygen that was there in the beginning, but now this oxygen as well has a -1 formal charge. Let's move to the answer for G, and we see now only 2 curved arrows. So we have a lone pair moving from that oxygen with a -1 formal charge. So now we have created a double bond between nitrogen and oxygen over here on the right. Nitrogen had 4 bonds, and then it will still have 4 bonds even after the left side, that oxygen, the nitrogen-oxygen double bond, those pi electrons become a lone pair on the left-sided oxygen, and that then has a -1 formal charge over here. The answer for H shows us the lower of the 2 curved arrows moving electrons in that double bond. So a new double bond is created here, but we also created an electron deficiency over here. So we're going to have a formal charge of +1 on this carbon. And then the second arrow shows movement of the double bond in the carbonyl to become a lone pair on the oxygen. So we have a -1 formal charge above on this upper oxygen.